Students, welcome back to my channel once again. This video I am going to teach you Oswald's dilution law, which is a very important topic from electrochemistry. Students, previously I have done Arrhenius theory of electrolytic dissociation. Those who haven't watched, please kindly watch that video and try to understand so that Oswald's dilution law followed will be very easy for you. Okay, so what do we learn under this Oswald's dilution law? Without any delay, let's move on into the video. The conductivity of an electrolyte, it increases with dilution. What is meant by dilution, students? So adding water or a solvent to an electrolyte, that means we are reducing the concentration. That means we are diluting the solution. So, whenever we dilute an electrolyte, the conductivity of such electrolyte increases. That's what I mentioned here. The conductivity of an electrolyte increases with dilution. Suppose you dilute and dilute and dilute. That means you add water. Then what happens? The conductivity will be maximum at infinite dilution. Okay. So, at maximum point, the conductivity also will be maximum. Now, this can be explained by Oswald in accordance with Arrhenius theory of ionization. Yesterday, in limitations of Arrhenius theory, in the previous video, we have seen that Oswald's dilution law was derived on the basis of Arrhenius theory of ionization. Okay, so that's what here I mentioned. This Oswald's dilution law can be explained in accordance with Arrhenius theory. Now, and if we see, this is applicable only to weak electrolytes. So it fails when applied to strong electrolytes. This sentence gives the meaning, students. Okay. Now, so what did we learn from Arrhenius theory? Suppose you add water to an electrolyte. It gets dissociated or it gets ionized into two particles, one having positive charge and the other having negative charge. Okay, so positively charged particles we call them as cations and negatively charged ions are called as anions. That's what I have mentioned the next sentence, students. According to Arrhenius theory, when an electrolyte is dissolved in water, it is ionized into two particles. One carries positive charge and the other negative charge called as cation and anion. Below I have given a reaction. What is it? CH3COOH. What is CH3COOH, students? Acetic acid. Suppose you add or you dissolve acetic acid in water. What happens? It dissociates into positive and negative ions. CH3COO minus acetate ion and H plus ion. Okay. And Arrhenius theory also explained that there will be an equilibrium existing between the ions and the undissociated electrolyte. Okay. So, how to represent this sentence in the form of a reaction? CH3COOH gives CH3COO minus plus H plus. So these are the ions, students, and this is the undissociated electrolyte. So this is the equilibrium sign. That's what this sentence gives the meaning according to Arrhenius, right? In the Arrhenius video, you can find all these points, students. So the same reaction is written like this according to Arrhenius theory. Part of the electrolyte which is undissociated and part of the electrolyte which is dissociated. So now the same principle is applied to an electrolyte AB by Oswald. Okay. What is that principle? There exists an equilibrium between undissociated and dissociated electrolyte. He has taken an electrolyte AB in general, students, and he applied that principle. So how can it be shown? AB gives A plus plus B minus, and there is an equilibrium sign between undissociated and dissociated part of the electrolyte AB. Okay. Now, suppose let us assume that the concentration of AB in the beginning, okay, let it be 1 mole. How much? let it be 1 mole at the beginning, the concentration. That means it did not dissociate into A plus and B minus. At that time, its concentration, let us assume it as 1 mole. Okay. And let alpha be the degree of dissociation. That means what? After AB gets dissociated, alpha part of AB dissociated into A plus and alpha part of AB dissociated into B minus. So that what do we call alpha? It is degree of dissociation. That means it shows us how much portion of the electrolyte is being dissociated. Now according to law of mass action, okay, you all know K is equal to A plus concentration into B minus concentration by AB concentration. Let it be equation number 1, students. Okay. So this is we are writing from law of mass action for this reaction. Okay. A small table can be generated here from this data, students. Okay. So the table contains the contents in the table. This is the electrolyte, 1 mole of the electrolyte. Next, this AB being dissociated into A plus and B minus. So here initial number of moles. So initial number of moles means before the reaction has started, AB concentration is 1. So it's not dissociated. So 0 and 0. Okay. Next is number of moles at equilibrium. So whenever you are seeing this equilibrium, that means AB, the reaction started and AB is dissociated into A plus and B minus. Okay. So what did we write here? Alpha be the degree of dissociation. Okay. So that means alpha amount of AB is being dissociated. So how much will be the concentration of AB now? 1 minus alpha. Okay. So how much of A plus is produced? Alpha. How much of B minus is produced? Alpha. Next, concentration at equilibrium. So how do we get concentration at equilibrium, students? So number of moles at equilibrium into concentration. So C into 1 minus alpha. Okay. Next, A plus C into alpha, B minus C into alpha. So concentration, we all know that C is equal to 1 by V. So instead of C, if we write 1 by V, now this becomes 1 minus alpha by V. This becomes alpha by V and this becomes alpha by V. Okay. So written, students, can you see, ma? Right. Understood this table? So before dissociation, after dissociation. Now this is concentration at equilibrium. 1 minus alpha by V and alpha by V. Okay. So let us proceed. Now substituting concentration at equilibrium in equation 1. Go back and check once equation 1, students. What did we write equation 1? K is equal to A plus concentration into B minus concentration by AB. Now we have the concentration of A plus, concentration of B minus and concentration of AB at equilibrium. Just we will substitute the values. Okay. Now K equals to alpha by V, A plus concentration. B minus concentration, alpha by V. AB concentration, 1 minus alpha by V. Okay. K is equal to alpha by V into V by 1 minus alpha. So V gets cancelled and what remains? Alpha into alpha square by V into 1 minus alpha. Again, students, V gets cancelled. Alpha into alpha square, V into 1 minus alpha. Write it as equation number 2. Okay. The same can be shown like this. K equals to C into alpha square by 1 minus alpha. Why? Because this V equals to 1 by C. So previously we have seen C equals to 1 by V. From the same equation, V equals to 1 by C. Substitute V equals to 1 by C here. So it becomes K equals to C into alpha square by 1 minus alpha. Mark it as equation number 3. Okay, students, again. So substituting equilibrium concentrations in equation 1. K equals to alpha by V into alpha by V by 1 minus alpha by V. So after simplifying, k equals to alpha by v into v minus 1 by 1 minus alpha. K equals to this and this gets cancelled. What remains? Alpha square by v into 1 minus alpha. The same can be written as k equals to c into alpha square by 1 minus alpha, since v equals to 1 by c. Okay. Now you mark the two equations as 2 and 3. Now equations 2 and 3, we call them as Oswald dilution equations. Okay students, both 2 and 3 are called as Oswald dilution equations. Okay, we all know that for weak electrolytes, alpha is very small. Do you know the reason students why? Why weak electrolytes are, what is alpha? Degree of dissociation. Why it is very small for weak electrolytes? Because weak electrolytes are the electrolytes which can be partially ionized. When it is partially ionized, what does it mean? It produces less number of ions. That means degree of dissociation will be small. Hence, from this sentence, 1 minus alpha will be almost unity in the denominator students. Okay. So Ostwald's dilution law is applicable only to weak electrolytes we have seen. So 1 minus alpha, degree of dissociation in the case of weak electrolytes will be very, very small. So when compared to 1, alpha can be neglected. So this 1 minus alpha is almost equal to 1. So when 1 minus alpha is almost equal to 1, how will these two equations change students? K equals to alpha square by v, k equals to c into alpha square, because alpha is very small in the case of weak electrolytes. That's what I mentioned here. Equations 2 and 3 are called as Ostwald dilution equations, and for weak electrolytes, alpha is very small. Hence 1 minus alpha will almost be unity, and hence equations 2 and 3 become k equals to alpha square by v and k equals to c into alpha square. Okay. Now from this, students see here, from this alpha square will be equal to cross multiplication k into v. Okay. So alpha will be equals to root kv. Okay. So if we remove this k, alpha is directly proportional to root v. Okay. So mention it as equation number 4. Okay students, understood here? Now what do we understand from equation 4? Alpha proportional to square root of v. From equation 4, what do we understand? We understand that what is alpha students? Degree of dissociation. What is v? It is volume, nothing but dilution. So it is directly proportional to square root of volume or dilution. So directly proportional means you know the left side portion and the right side portion. When there is a direct proportionality, so if left side increases, right side increases, right side increases, left side increases. So as volume increases, alpha increases. Alpha is increasing, degree of dissociation is increasing. What does it mean? Number of ions increases. Number of ions increasing means conductivity increases. So alpha increases. So till how much point this alpha can be increased? Till infinite dilution. How much we can dilute the electrolyte? Till that point it can be diluted. So at maximum dilution or infinite dilution, ionization is 100% complete and maximum number of ions are produced, and hence conductance will or conductivity will be high. That is what equation 4 describes students. Okay. Degree of dissociation directly proportional to square root of volume or dilution. What does it mean? It means that as volume increases, degree of dissociation increases. You always remember degree of dissociation increases means number of ions will be increased. Number of ions increasing means conductivity will be increasing. Therefore, at maximum or infinite dilution, ionization is 100% complete and the number of ions produced will be maximum and hence conductance will be high. Here you should mention limitations also, students. Here we can find two limitations in Ostwald's dilution law. What is that? It is applicable only to weak electrolytes and it is applicable only to dilute solutions. Okay, students. So this is all about Ostwald's dilution law. Okay. So kindly note down all these points, and examination point of view, this will be sufficient, students. Okay. Please kindly write all the points in your notebook or take screenshots of the video, and if you can prepare directly from your phone, you can prepare. Okay. So first try to understand Arrhenius theory and then learn Ostwald's dilution law. It's a very, very important question from electrochemistry students. Okay. And please, I request whoever is watching, please like the video and share the video, students. Whoever is watching for the first time, don't forget to subscribe. Okay. So meet you in the next video with a new topic, students. Until then, stay tuned. Take care. Bye-bye.